example that we did in class, the very first example when we learned this material. I would say this one's actually a pretty basic example here, but you're pretty much your final structure that you should get. I'm just going to draw out your final structure is N bonded to 3 fluorines. Okay, and each of my fluorines is going to have 6. Each of my fluorines is going to have 6 dots on it. I forgot 2 on this one. Okay, so each of my fluorines has 6 dots. And I really need to invest in the trackpad because this is not cool. Okay, imagine that's 2 electrons, apparently. Add another one. That's 1, 2. Okay. And then you're going to have your last 2 electrons on your nitrogen. Everything's happy, and you're pretty much done with that one there. The last one I am going to go over just because we haven't done one like that on this example yet. It's CO. So first I take my inventory. There's 1 carbon, and there's 1 oxygen, times my number of valence electrons. So my total is 10. So next I'm going to bond my C and my O. So I've used 2, so I'm down to 8. Okay. Now next I'm going to go and start to try to put some on my oxygen. So I've put 6 on the oxygen, so I have 2 left. And then that leaves me 2 to put on my carbon. So my oxygen's happy, but my carbon's not. So one way that we know to kind of combat that, to kind of go away from that, is to share electrons. So what we want to do here is we want to take 2 from here and we want to bring it down and form a bond. Okay, and that's going to give me 6 electrons around the carbon. So I'm going to also take these 2 and also share them. So my final structure is going to look like C triple bonded to my O. My O is going to have its 2, and the carbon's going to have 2. And that's kind of looks weird, but that's going to be the structure you're going to have for everything to be happy in that example. Okay. Now this is the last thing that you really have to know for the test. It's valence shell electron pair repulsion theory, which I'm just going to say as VSEPR. Basically, you need to know the bond angles for linear, trigonal, planar, bent, and tetrahedral shapes. All right, so y'all. Oh no. Let me go back to that slide real quick. So when I'm saying know the bond angles, what you want to know is that you want to know that linear is going to have a 180 degree bond angle, trigonal planar is going to be 120, and tetrahedral is going to be 109.5. I don't think bent's going to show up, but bent can be either 120 degrees or 109.5 degrees, depending on how many bonds you have and how many lone pairs you have. But what I'm really wanting to focus on is how to figure out the shapes. So I'm not going to go through how to figure out the Lewis dot structures because I've already done that on a previous slide. But what I want you to do is, so if we're doing this for carbon dioxide, our first step is to draw the Lewis structure. All right, so the Lewis structure for carbon dioxide. It's going to look something like this. Okay. The next thing that you want to do is you want to determine how many regions of, or how many areas of electron density do you see, all right, or electron concentration. So here I want to look around my central atom, which is my carbon. There I have one, there I have another. So the things that are going to be electron dense regions or electron areas of high electron concentration are going to be if you have an atom bonded to that central atom. So in that case, I have that here and here, or if I have lone pairs. And I'll show that on a future example that I'll work with y'all. But if you have two, like in this case, you just have two regions, that's always going to be linear. All right, and that's what you're always going to see in that example. Okay, if you have two regions, it's always going to be linear. So the next example that I have for you is nitrate. We've already actually drawn this one. Okay, so you should have already seen what nitrate kind of looks like. Okay, and I'm not going to draw all these extra electrons on these oxygens. Just know there's 6 there and 6 there. So my next step is to find out how many areas of electron concentration I have. Well, first I'm going to count how many things are bonded to it. How many bonds do I have? Here I have 1, 2, 3, and I have 0 lone pairs. All right? If I have 3 bonds, which in this case I do, I have 3 bonds, 0 lone pairs around my central atom, which in this case is nitrogen, then I'm going to say that my structure is trigonal, so T-R-I-G-O, trigonal planar. So they're all staying in the same plane. So the bond angle you're going to see in this case is 120 degrees. So that's what you'll see for that example there. For the next example, we're going to go ahead and do sulfur dioxide. It shows, here I'm going to actually skip that one. Actually, no, that's a good one to do. Alright, sulfur dioxide, it shouldn't have that minus on it. I don't know why it has that. But for the sulfur dioxide, it's SO2. Wow. It's going to have 6 dots there, 4 there, and then 2 there. So that's 8, 9, 10. Yeah, so that looks good right there. So that's going to be the structure you're going to see for SO2. So when I'm counting out my regions, here's a region that has something bonded. Here's a region that has something bonded to my central atom. And this is what I'm talking about when I'm talking about a lone pair. So I have 3 regions. Okay, so I have 3 areas of electron concentration. All right, 2 of them are from bonds. All right, and 1 of them is from a lone pair, and I'm just going to abbreviate that LP. All right, so 1 of them is from a lone pair. And when I have 2 things bonded and 1 lone pair, what I'm going to end up seeing is a bent structure. Okay, so my molecular shape there is going to be bent. Couple more here. I definitely want to go through and do methane. Alright, so methane, CH4, you're just going to have your H's. Remember, H's only need 2 electrons to be happy, to have that full valence shell, to have everything that it needs. So that's going to be my structure for methane. Okay, so when I'm looking at regions, I have 1, 2, 3, 4. If I have 4 areas, okay, and all of them are bonding regions, then I'm going to say that that's tetrahedral. Tetrahedral. And it's on the last slide, and it's also in your notes that you have to know for tetrahedral. So I'm not going to really pretend like I need to draw that to be super nice. I know you probably can't read it at all, but hopefully you're kind of listening along as well. But that shape right there is going to form tetrahedral shape. Next is ammonia. Okay, so ammonia is NH3. So you're going to have all these nice little H's. Remember, H's only need 2 to be happy. I'm going to end up with a lone pair on nitrogen. Okay, and when I do my regions or my areas, I have 1, 2, 3 that are bonds. So I have 3 bonds. Okay, and I have 1 lone pair, which I'm going to say is LP again. Okay, if I have 3 bonds and 1 lone pair, then that's going to be trigonal pyramidal. And see if I can jump out of the screen for a second. I had these balloons next to me. Oof, hot mess. Okay, so I don't know. Hopefully you can see this. I don't know. But this is an example. So here I have my lone pairs. My orange balloon is going to be my lone pair. And then my yellow balloons are going to be my actual atoms. So this is going to be pushing away. Because remember, all the electrons are going to repel each other, the electron regions. And so these yellow balloons here kind of form a pyramid. And it's got a triangle base. So we say that the shape of this is a trigonal pyramidal or a trigonal pyramid. Is the way you're typically going to see it. Not really with that AL, I shouldn't have added that, but it's a trigonal pyramid. There's one more example to do, and this one's actually in your notes, so you've actually already seen this one in class, but H2O is also going to have four regions. Okay, so here's one region, two regions. So I have two regions that are lone pairs, and I have two that are from bonds. Okay, so I have four total regions, so my bond angles are 109.5. But in this example here, I have my two sets of lone pairs, my orange balloons again. And the way that you're going to see this shape right here is, once again, with my blue balloons, my atoms, my hydrogen atoms around my central atom, you're going to see a bent shape again. So if you have two regions of lone pairs and two bonds, that's going to be bent. You need to kind of have an idea of that. Some people can visualize it in their head pretty easily. Some people actually need to memorize, hey, if I have two sets of lone pairs, it's bent. If I have one lone pair and then three things that are bonded, then it's trigonal pyramid. So those are the kinds of things you need to be able to do. So like I said, if there's anything that you didn't understand, the great thing is that you can rewind. If there's something that you understand really well, then you should have hopefully fast forwarded through it. If you watch this whole video, I don't see you doing poorly on the test. But refer to your notes, ask a friend, email me, and also try to come in and see if I can help you out. Those are the options that you have before this test, and I think that if you take advantage of those options, then everything will turn out just fine. Alright, so I think I'm going to go ahead and see if I can get this, see if I can remember how to get this